Hello everyone, welcome to my channel. My name is Binyo Yan. I'm currently a postdoc working with Professor Gerber Cedar at the University of California, Berkeley. And this is my personal channel for sharing my research experiences as well as a daily life as a material scientist. So today I'd like to talk about something not directly related with research but quite connected with it. It's about how do we visualize a better picture and image of a scientific concept. So let me first go through the conventional ways that we visualize a scientific concept. So one good example of it is the phase diagram. So this is an example of a water phase diagram where we plot the phase stability of water as a function of the temperature and pressure. So with this kind of a phase diagram, we can learn a lot of the basic concept of thermodynamics, right? We can learn about what is the stable phase of water under different state. And we also learn the concept about phase boundary and how to kind of trace down these boundary conditions when a water going to transfer from, for instance, gas to liquid or from liquid to solid, right? So with this kind of a phase diagram, we can know this abstract idea of phase equilibrium, and phase transformation. On the other hand, if you're a student of maybe solid-state physics or material science or chemistry, you must have learned about atomic structure, right? So specifically for crystal structure. So crystal structure is a concept to describe a periodic arrangement of atoms in an inorganic crystalline lattice, right? So in that case, we draw this lattice by putting atoms in specific positions and also put this kind of a chemical bond to show how atoms are connected with each other. So we usually draw these atomic structures to tell you what exactly and what type of materials you are looking at. So those are actually the conventional ways we visualize the scientific concept. We basically draw a diagram on the paper or on the screen. However, we have to accept, and I'm pretty sure you have this kind of experiences, sometimes a scientific concept is not so straightforward, And one major reason of it is like sometimes scientific problem come with a high dimension, right? That kind of a complicated sense because we cannot see that in a very straightforward way. Even for something like a crystal structure, as I described, crystal structure is not so trivial if you are a first-year undergraduate student. So actually dating back to my undergraduate classroom, the professor gonna bring some toys like this, like gonna be like some Lego style of crystal structures made of a plastic or made of wood or made of metals, right? So we kind of play around with it, and the professor gonna hand it over to a student, and then we sort of play with it for a few seconds for each one of us, and that kind of give you a sense about the symmetry and also like the feeling of atoms and also like the topology of atom in the crystal structure, right? So those kind of tools should be very helpful for us to understand what has been described in a textbook, even though sometimes we have pictures showing you what is FCC, but by touching those crystal lattice can always give us a better feeling of those signs. However, as a future professor myself, I have to say that this is not necessarily very convenient as a professor. And it's not even so convenient for a student, to be honest, because this kind of a thing requires a lot of time and effort, right? So a professor have to carry, like 5 and 6 this kind of a toy to a classroom. And assuming that if I have a 50 student in the classroom, each student cannot really interact with this kind of a model for a long time. So if it's a really complicated thing, we don't really have enough interactions with this physics concept. So nowadays, we actually have a lot of tools to make more interaction with this kind of a high-dimensional scientific concept. So today I would like to give 2 examples. Well, the first one is virtual reality. So here, we kind of design an application to apply the idea of virtual reality. So this is an application developed together with my colleague Tanjing He, a PhD student at the CETA Group. So we basically want to develop a tool set for us to play with the crystal structures. So here, my colleague is kind of trying to understand this complicated crystal structure of agilodies, which is the superionic conductors. And it actually conducts lithium in a fast fashion. And what he's trying to do here is to use this handle to really point at different locations of the lithium, which you can see in this kind of a text in the video. Whenever you put your cursor into some places, it's gonna react and tell you, what exactly is the position in a crystal lattice, which is the fractional coordinate of that location. And also you have kind of a number after this equal symbol, right? So that tells you about the percentage of a probability of finding a lithium when this material conducts lithium. So with this kind of a tool, you can really play with the crystal structure as long as you want, right? To really understand the symmetries and the bond topologies and how different atoms are connected. And also in this case, you can learn about how lithium is gonna move in these crystal structures, right? So this sounds like an interesting idea. Virtual reality is really something very interesting, but it's not so convenient sometimes as well. So in order to have it, you have to thank to your professor or your university or sometimes your parent because it costs money. So I should really thank my advisor here at UC Berkeley who actually gave us a few thousand to set up this kind of equipment. So usually a VR equipment costs about $1,000 to buy this kind of a helmet or like a handle or the lighthouse. And at the same time, you also need a very good computer, at least a very good GPU to really run these VR applications. So a good computer means additional about $2,000 to $500. So that's gonna be not something that is so reachable, especially for an undergraduate student. So as an alternative, we actually have some other ways to visualize a scientific concept. That is something like this. So I'm pretty sure that a lot of you guys have played with this game, right? So it's actually one of my favorite mobile games, Pokemon Go. So we can use this kind of augmented reality techniques. So whenever you put a camera on a specific image, and the application gonna tell it and project that into a 3D model. So this is exactly what is behind this augmented reality. So again, we kind of designed this augmented reality to help us better understanding atomic structures and also material science. So here again, my colleague Tanjing actually trying to use this augmented reaction app to understand the complicated 0TM population of a new lithium-ion battery cathode materials, which is called the disorder oxide materials. And we know that in this kind of materials, we have this local structure, which is not so straightforward sometimes. So we decided to kind of connect those images in the paper to some 3D atomic structures. So whenever you put a camera onto the paper, it's going to show you how atoms actually connected to form a population network. And the science and basically the design behind this app is that we want to establish some three-dimensional model using a tool, for instance, like SolidWorks. And then we propel these models, for instance, like this kind of a population network. And then we try to connect that with a scientific image. So that can be a picture on a paper, or that can be a picture on top of a screen. And then what we need to do is to design a mobile app that everyone can install in their iPad or iPhone or any kind of a smartphones. So in that case, whenever you put a camera into this scientific image, we can learn about what exactly happened in the three-dimensional world. And with this kind of a tool, we can play something more complicated. Like we can play with something like diffusion trajectories of materials. So this is really a 3D trajectory when atoms move into a 3D crystal lattice. So as a material science working in the field of solid state electrolyte, to be honest, in a lot of situations, it's not so convenient to even show to expert in this field, because when you draw this kind of a probability distribution, it's not so straightforward to illustrate how how it distributes in this 3D crystal structure. So as a consequence of fact, we're gonna design this kind of augmented reality applications to show you, like whenever you put a cell phone on the screen, you can play with these isosurfaces. You can rotate or move. These are kind of crystal structures as you want. So let me show you. My colleague are kind of moving it and trying to rotate and these structures to kind of understand how does this connect to each other from different kind of atomic site. And also, whenever you can move on the screen, or you can move on top of a paper, as long as the camera sees this kind of image, it's gonna react and project this kind of a three-dimensional atomic models, and that gonna tells you how exactly what is the science behind it. And with this kind of a tool, now we can make sense more vivid, right? And also in a kind of a lightweight version. And this sounds like something cool, and maybe you're gonna have the puzzle that like how long or how expensive or how much time we're gonna spend in this kind of concept. Assuming that you are a university professors, like how long I'm gonna devote to prepare materials for teaching the class, right? So this is gonna be a problem, which is a very realistic one. So what I want to mention here is like this is not really rocket science, like this is something already existing in the field. We can find a lot of this kind of virtual reality applications and also a lot of this kind of augmented reality applications. For instance, like Pokemon Go. It's a very good example, right? So to give one demonstration about it, this is actually something that is happening right now, not just in Cedar Group, but in internationally. There are a lot of universities who is trying this kind of a concept. And here I kind of introduced two papers from Journal for Chemical Information and Modeling. And these guys are actually from the research group at the University of Bristol at the United Kingdom. And they're actually trying to use virtual reality to play with atoms in the fashion of molecular dynamic simulations. So in that case, you can directly manipulate molecular dynamic simulation and see how does this atom interact with each other in kind of a Brownian motion like fashion, or you can apply different kind of conditions to this system to see and actually feel how does atom move and interact. So this is actually something happening right now, which you can see these are two papers actually published last year. And also for augmented reality, it's also not a rocket science. And it actually can be convenient in a lot of cases, right? Because what you're gonna need for this is gonna be a cell phone. And here is again another paper from a professor at the Southern Illinois University. He or she actually designed this kind of applications. So whenever you put a cell phone on top of a molecular formula, what's gonna appear on the screen of your cell phone gonna be an interface that you can write down and understand and decompose and do whatever you want to make a better idea what exactly does this molecule mean. And another convenient thing to understand it also to put it, like on equipment, a experimental device to help you understand what exactly happened to this device and what does each part of this device mean. So the reason I show this technique here is, first of all, to show you with some of my interesting experiences. We kind of spent a few months to design these interesting applications. And on the other hand, it's also to kind of demo what's going to be the next form of education can be. Like as an incoming professor, I'm also thinking about the idea, like how can I attract students' attention in the classroom? So in my opinion, I think virtual reality and actually in a lot of cases, augmented reality gonna be very helpful to help people understand or also attract students' attention. And one additional my point of view here is like in current stage of a pandemic, we may also want to use this kind of a smart system to give tutorials in the laboratories to students, especially when we want to reduce the in-person contact. Then what we need to do is to make sure students go to a laboratory room and use the cell phone to understand a lot of the scientific details about what exactly does this equipment mean and how it operates, and the student can look at the device and also look at the video on the cell phone to really understand and interact with the science. So that is actually pretty much about my video. So I hope you really enjoy it, and I encourage you to kind of leave your kind of feelings, and also I encourage you guys to discuss with me or on the bottom of this video about your feelings, and if you have any questions about these two techniques. And that's pretty much about my presentation. So it's kind of a random chat with you guys and sharing my recent findings. I'm actually a little bit excited about it. And thank you again for your attention. And I will see you in my next video.